Hi and welcome to episode 4 of Watch Me Code. So if you've been following along, what we've got so far is we've now got a way where we can collect a bunch of projects and have them be automatically discovered. The issue we're going to find, if this is sufficiently successful, is that we've now got to configure all those projects by putting in place a Jenkins file. Now, with the Maven project, we have the luxury that basically every project of the Maven project is going to be guaranteed to be built with Maven. So what we'd really like is we can just have a standard build and apply that to everything consistently. So I thought I'd take us through doing that. So let's start from the beginning. We should probably get our hands on a test Jenkins just to use for the purpose of this. So where I download the Jenkins. We go with this guy, generic war. So while that's downloading, we also want to mvn arch generate. We also want a sample project that we can actually build, rather than having to go and deal with messing around with the various different Maven repositories and adding the appropriate bits in. Let's just create a basic Maven project that just builds. So local domain, local host, sample project. That'll do, and that'll do, and that'll do. There's sample project, cd sample project, cat.git ignore target slash control D git init dot git ignore star git commit. So we've got a Git repository, clean, verify, with a Maven project in it, and that Maven project builds, and everything is hunky-dory. So now let's get ourselves a Jenkins. And mv total/down Jenkins dot cat on Jenkins h bin/bash. Now bash script directory. There is a particular sequence of commands that gives you the script directory. So let's use those, and then exec export Jenkins home on equals quote dir /Jenkins end quote, and exec java -jar string dir /Jenkins.or chmod. So this should give us a Jenkins instance. And we need that. Local host 8080. Bum, bum, bum. There's our admin password. Install suggested. Let's let that run away. Now, what we're going to end up doing is pipeline shared libraries. So the idea behind the pipeline shared library is we can define a standard build step, and we just basically give every project this standard build step. So if we go back to here, at present we've got this guy here. So let's go and touch Jenkins file, git add Jenkins file, and Atom. So I've got this right. Oh, I have Atom working. Grand. Okay, so like we could go with, you know, pipeline and stick in the standard thing, agent any, and all that jazz. But what we really would prefer is that, because we're going to have hundreds of projects, we'd rather just be able to say, okay, just use the standard build. So what we really want to be able to do is say something like ASF Maven TLP build. And that should build any of the Maven, well, let's put in standard in there. So it's the Maven top level project standard build. And if we just stick that command in there, then away we go, and that's it. That's all you need in your Jenkins file. And then elsewhere, we actually define what this means. And then if we update that definition, all the repositories that are using this will then all automatically get that new build process. So if we go back here, I'm going to continue as admin, start using Jenkins, manage, configure global security, and I'm going to use Unix group. Save. New item. Now, multi-branch pipeline. Sample project. PWD. So we've got the sample project. We're going to add a branch source, which is Git. Now, with the other stuff we've done, we wouldn't have to do all this, but we're trying to work around having to do any of these changes and just basically get the project building as we want. So this is what we're going to start with. And let's go with a pipeline Maven example. So here we go. This is what we want for our pipeline. Atom. So let's start with this guy. So we're just going to go sh mvn clean verify. So that should be a minimal Jenkins file just to get started. And, oh yeah, Jenkins file, commit, add a Jenkins file. Right. So now if we wander back up here, scan now. So if we scan, we should see what we get. So we've met criteria. And now if we look here, here's the master branch. So the build. And let's go back here. I'm going to just knock the font down one. So you can see here, we've got the checkout SCM and we've got the build. We can look at the logs and you can see it's done, the build and all that. Now, that's fine because we have a basic project like that. On more complicated Jenkins instances, people will oftentimes configure tool installations. So you may have several JDKs. So we might have Java 7, which might be, say, this guy. We might have another one, might be Java 8, which might be this one, and we might have a Java 9. That one will do, and fine. Now I need to go and provide accounts and all this, but you'll notice here that these are user supplied names. I mean, I could call this JDK7. I could call this Java JDK 8 latest. There's all sorts of names I can give to this. And when we want to get the particular Java tool so that the build actually uses that tool, if we're using this kind of tool installer system, then we need to actually have the tool installer name. Now, if we were building only on Linux-based machines, the way we typically handle that would be we'd use a Docker image for each of the different build environments. And then we could, instead of saying agent any, we could say agent and specify the Docker image, and that would remove that need. But instead, for Apache, we have this great thing, and a lot of people probably have it, where you have to build on Windows and Linux. So we're going to have to live with these global tool installers in order to give us our Jenkins and things like our Maven. So 3.5.2 is fine. I'm just going to get rid of these JDKs. I have a better way of getting the JDKs. Delete that guy. And delete that one. And now use Java 1.780 echo Java. So this is my Java 7. So this is Java 7. And I'm going to add JDK. No, this isn't. No. Well, Java home. There we go. So that's Java home. This is Java 8. I'm not going to install automatically. Use Java 1.8.4.4 is fine. And this is the Java home for this one. So I've got my two Javas. I've got a Maven version in here, and we hit save. Now, at this point, in our sample project, we want to change this. So we want, we want to build with Maven, and we want to build. Let's build and so we want two builds. Like we've build J7, and let's say build J8. So we want to do both of those, and so now we need to use the appropriate version of doing this. So what we do is we go with Maven. So this, where am I? With Maven pipeline example. So with Maven lets us go with specifying various different properties. So we can specify the JDK, and we can specify various different ones. Let's see if we can get some example code. Well, we'll start with the basic. We just say with Maven, and we wrap this guy. And we'll do it the same here. With Maven. Now, we're not currently specifying the JDK, but we'll sort that out in a sec. And where is the property it specifies for JDK? Version of the JVM. Let me see. JDK. Right. So JDK and JDK. Now, is this Java 8? This should be Java 7. Now, I don't think this is going to work, but we give it a shot anyway. Git commit update say. Right, let's go back to this guy and trigger a build. Yeah, failed. So, no such DSL. Oh, right. Okay, I've only got standard plugins available. Pipeline Maven. There we go. Install it, restart. Let's go back to this guy and build again. It should be working. So using JDK Java 7. And use JDK installation Java 8. And that's done that. So if we now go back to build 3, we have test results. We have fingerprints of artifacts produced by the build. We have all the nice stuff. So that's a nice, simple enough pipeline. But you know, we wouldn't want to have to put this in every single one. So what we want to do is we want to create a shared library. So pipeline lib git init dot. Right, so let's go back here, sample project configure, and we're going to add in a pipeline library, pipeline lib, default version master, load implicitly, I don't want that, modern SCM, git, this guy there, discover branches, that's that. And what we need to do is we need to create the appropriate structure. So what you do is in that you can have various different classes and various different things, but the key thing is in vars we can define what are known as custom steps. So let's grab this guy. So if we over here, right, okay, there, vars, it's vars, isn't it? Yeah, vars. Vars and touch, vars / ASF Maven TLP std build.groovy. Atom dot vars ASF Maven build state. So for this guy we need right def call. So let's go over here, grab this guy, and this window. If we just return this, there we go. So pipeline, and save that guy, and then ASF Maven TLP std build, save that guy. So now git add vars git commit, right, and see / project git commit say switch to standard build. Well, I always make that mistake. Right, now, if we go back to sample project and we build again, and we reload, and it's building. So you can see now, in this case, what we've actually got, if I click at what the main script is, so this is the main script that we have, and then here's the actual top level project thing that's come from the other Git repository. So we can make all the projects just have a simple build step like that, and then we can have that just return this pipeline. And we can actually do even better than that. I'll probably do that in the next video. And that is, we can start putting in configuration items in here. So we could say JDKs 7, 8, 9, say, and that would then say, rather than having to hard code building with 7 and 8, it would say, okay, the project is allowed to say which JDKs it needs to build with. And, you know, it can say 7, 8, 9, and we can say maybe as well OS, Linux, Windows, and we can have defaults. So by default, maybe it builds with 7, 8, 9, and by default, it maybe builds with Linux and Windows. But if we know this is a particular project that we don't want to build on Windows, we can knock that out. Or if we know this project's only 8 and 9, we can knock that out. And so this allows us to have this, but all managed from this shared build, which is then distributed across every single project. So that's kind of how we can make things a lot better. And hopefully next time, what I'll try and do is I'll try and show us how we can actually make this into a really flexible build, especially tailored for the Maven project.